Hello, let's continue with part 2 of chapter 11.1 motion. All right, before we talked about the difference between speed and velocity, now let's talk about how we show motion on a graph. How can you show motion on a graph? You can show motion on a graph by recording distance on the vertical axis and time on the horizontal axis. Remember, vertical, horizontal. Then you can use the shape of the line of the graph to learn about the motion of an object. Calculating speed from a graph. On a graph of distance versus time, the motion of an object moving at a constant speed is a straight line. The slope of the line is equal to the speed of the object. You can calculate the slope of a line by dividing the vertical change of the line by its horizontal change. The equation below describes this relationship. Slope equals vertical change divided by horizontal change. Let's do a reading check. On a graph of distance versus time, what does the motion of an object moving at a constant speed look like? It should be a straight line. Okay? So if you show the distance on the vertical axis and time on the horizontal axis, the slope of the line is the change in distance divided by the change in time. Remember, the speed equals the distance divided by time. Therefore, the slope of a line on a graph of distance versus time is the speed of the object. For example, you can determine the speed of an object in the plot below here. Okay, so let's look at this. Okay, graphing skills 12. What is the independent variable in this graph or figure? So remember, independent variable is the variable that we are changing. So what are we intentionally changing? We are intentionally changing time. Okay? Okay. Now, suppose you choose two different points on the line to calculate slope. What would you get? Would you get the same result for slope every time? Yes, it is, because the line is straight. Therefore, it doesn't matter which two points you use to calculate slope. You will always get the same answer. Okay? All right. So to calculate the slope, we're going to take 2 points. So let's see, maybe I don't know if I can, maybe I can put an X. So we're going to put an X here. Okay, so one is 1 second. The other distance is 6 meters. We are also going to look at 4 seconds. So those are our 2 points right there where I put X's. Okay, so then we would take the vertical change. Okay, the vertical change is 12 minus 4, minus 6, which gives us 6 meters. The horizontal change is 4 minus 1, which is 3. So our slope is actually, our speed is 2 meters per second. So the slope of this line and the speed of the object is 2 meters per second. Okay, interpreting slope. Remember that the speed of an object is equal to the slope of the line describing its motion. The steeper the slope of the line, the faster the object is moving. For example, the graphs below show the motion of two cars traveling at different constant speeds. Okay, look at both of these graphs. How can you tell that the cars are moving at a constant speed based on the information in the graphs? That is because the graph shows a straight line. So the graph shows a straight line. Okay? All right. Now, on the graph of distance versus time, the motion of an object moving at variable speeds is a curved line like this. For example, the graph shows the distance versus time for a car that is speeding up. Okay? So we can see this curve. So speeding up. Okay, even if the object's speed is changing, you can use a graph of its motion to find its average speed. Remember, the average speed equals total distance traveled divided by total time. You can find both the total distance and the total time for this graph, then divide the distance by time to calculate the average speed. So what is the average speed between 0 seconds and 5 seconds? Okay, so let's look at it. So we have total distance equals 60 meters. Do you see we got that from 0 to the 5 seconds? We went 60 meters. Okay, and total time equals 5 seconds. Okay, so we want V equals, so our speed equals distance divided by time. Okay, so our speed equals 60 meters divided by 5 seconds. Okay, so our speed is going to be 12 meters per second. I hope you understood how we use that graph to find the average speed. Okay, this is the end of chapter 11.1 on motion. Go to Infinite Campus to finish completing your homework for this section. See you tomorrow. Bye.